All right, questions from the homework. Let's go to the front page if you don't mind. So it's 0.5. Go ahead.
10.
Number 10. Name the intersection of the plane ONT. So ONT is the top plane. And then QRS. QRS is the side plane. So top and the side, the intersection is going to be line TQ. So it's the top and the side. TQ is where they intersect. Other questions from the front page up to number 11. Yeah? 9. Number 9. Decide whether each set of points are coplanar. PMNO, PMNO. Yes, because that's all on the side. Stop. STO. Yes, they would. The reason why stop would work is you have a diagonal plane that could work going from back, from like that corner to that corner. You could do a plane. That make sense? And then RSTO. RSTO. No, that wouldn't, because the 3 letters signify the side, and then you had like a corner way off. So RSTO is they are not coplanar because there's no way you can make it work. Other questions up through number 11. Yeah. 7A. Name the intersection of AB, line AB. We're going from the top. And DE. So name each intersection. 7A, it's point A would be the intersection of those 2 lines. Does that make sense? Yeah.
11.
Number 11. Name 3 planes that intersect at point R. So point R is that back corner. So you could have TSR, which is the right side, PRQ, which is the back side, and then the bottom of that would be SRP. You don't have to use 4 letters. You can define it by the 3 letters. So the right side, the back side, and the bottom side of the 3 planes.
So basically, you just have to have the letter R in it?
You don't have to necessarily have the letter R in it. You just have to use 3 of the 4 letters on that side. So the right side of that, you have QTSR. You just need to use 3 of those letters to name the plane that's on the side. Or on the top you have OQTN. You only need to have, or the bottom would be PMSR. You only need 3 of those letters to identify the bottom part of the plane.
So I could do like PMR?
Yes. Perfect. Any other questions up to number 11? Can I flip the page? All right. 12 and 13, is there anything there? Are we okay? Opposite pairs arrays, 3 non-collinear points we should be good with. Is that all right? Any problems with the algebra? 14 through 20. Any of those? Yeah. 17. 17, all right. Personally, I would choose to clear the denominator. You have 4 terms up there. Do you agree that I have 4 terms? Now, the term clear the denominator might always click for people, but what it means is I'm going to take each of my denominators, which happen to be 2, 4, and 5, and find the smallest number that they would all go into. I think 20 would work. That'd be okay? So I could say I'm going to multiply this by 20 over 1, this by 20 over 1, this by 20 over 1, and this by 20 over 1, which is just 20, right? And 2 goes in there, that's a 10. 10 times 10, I get 10x. And that goes 5 times, so that's going to give me -5. Equals, that goes 4 times, so 4 times 3 is 12. X comes along, and then plus 40, like that. Does that make sense how I did that? And then, going through quickly, subtract 10x. Cancel 5 equals 2x equals 40. Subtract 40. That's -45 is equal to 2x, so x is equal to -45 over 2. It's kind of a 2. All right? Any other ones from algebra? Going once? Going twice? Sold to the boy picking earwax out of his ear. Who was that? All right, make sure your name is on. Of course, mine look a little different because they're on the board. Let's see. Vocabulary construction. So you're using the tools of geometry to duplicate shapes. Bisect means you're cutting something in half. Okay, so far? Construct a copy of the segments. One endpoint should be on the given point. Okay? So, if you are just copying a segment, that means you're trying to find the exact measure of the segment, which means you should not use a ruler for it because there's amount of error for your ruler. So you're going to use your compass. And if you were to use your compass, you take your, get out of there, take your point, put it on one end, and you close up your compass. Get my finger out of the way. So you want your pointy end to be at the very end, and then I'm going to bring my compass down a little bit and then open it up a little bit further. Once your compass is the length that you're supposed to have, bring it down to your point on point N, and then swing an arc. So the distance from this point to anywhere on this arc is going to be appropriate. So I'm going to bring my ruler in, and I should be able to go just like this. Oops. Let's move that out of the way. So the distance from right here to right here is the equivalent distance that it was from here to here. And in geometry, it's not necessary to erase your arcs that you've swung. Okay, now if you swing arcs and you're going all the way around, you might be going a little bit too far, but I get it. So we're just trying to mimic the endpoint. So on this next one, talk me through, what should I do? Using my compass, where do I put the pointy end? Put it at the end. Oops, let's move that out of the way. Move it out of the way. Swing this down. Open up your compass appropriately. So that distance of your compass is now going to be the distance of your new line. Bring your object down. Put your point on the center, and then swing an arc. When you swing the arc, the distance from here to anywhere on this arc, because it becomes a radius of a circle, is going to be equivalent. Again, I'm not trying to measure it. I'm just trying to use my ruler as a straight edge. So from here to here is the equivalent distance as it was from here to here. Make sense so far? If you don't have these tools, it's going to be tougher to do these kind of things because I'm looking for arcs that you're swinging. So please, by all means, get over to Bare Necessities and buy the appropriate objects. May I move on? Next page. Construct a copy of the angles. The vertices should be on the given points. Okay. So let's see. Let's bring this down a little bit. So I believe what I'd like to do is I'm see how you guys have it. I'm going to have this here become point Q. Is that all right? I'm actually going to erase it because I don't want it on there like that. So I'm going to duplicate this angle. Okay? Question? Another sheet? Oh, you didn't get one? Couldn't count today. Sorry about that. Give it about 3 minutes. Someone's going to walk up with one. Oh, this is an extra. All right. You guys ready? And girls ready? Take the compass. I'm going to get it to an appropriate position. I'm going to put the point on the corner. Still with me? I'm then going to, I'm just going to hover that above. I'm going to keep it as a consistent distance, and I'm going to swing an arc that touches the line twice. Okay? Where two lines intersect, you create a point. So you put your point on the vertice, the corner. You open your compass a certain distance. You swing an arc that intersects two lines. Okay? Yeah?
Does it really matter the distance as long as it's in the...
Right. Nope. So you're not going to change the distance of this, but with this, you can then say, well, I have a point here and a point here. And being I have points there, you could say, well, we can call that X and Y, or whatever two letters I would like to use. Once you've done that, you're going to take your compass, you're going to move it over, put your point on the new one, and you're going to kind of swing a big arc. You're not quite sure. You're not quite sure how big it should be. Okay? So that distance from our new point is the equivalent distance it was from this point to this arc, because I didn't change my compass at all. Okay? So I've now labeled 2 points, X and Y. We have point Q. So we need to, from point Q, we're going to create 2 more points. So from point Q, I've just swung my arc. Semi-outside or something? I guess so. I'm going to break out with my ruler. Or my straight edge. And I'm just going to draw a straight line right through. Yeah. Green or purple? Green. Green. This one? This? Okay, so what I did is I had my compass, my point was on point Q. I opened up my compass a certain distance, and I swung an arc which hit my angle twice, or hit the 2 lines that made the angle twice. Kept the compass the same distance open, came over here and just kind of swung a big arc. Exploit it, make it a larger arc than what you'd known. I mean, I swung this size of an arc here. This one is obviously much bigger. I just need to make it take place. So what's taking place up here is this line right here and this line right here are the same. So I'm just going to name that back to be point X. So this QX is the same as that QX. All right? Once we've done that, I'm going to now take my compass and I'm going to put my pointy end on point Y. I'm going to close the compass. I'm going to rotate it so where I can get on there. Yours are going to be a little quicker. So what I want to do now is I want to measure the distance from point X to point Y. Measure the distance from point X to point Y. Does that make sense how I'm saying that? I'm going to keep my compass the same. I can rotate it around a little bit to make this a little better for me. I'm going to put my point, because I've already established point X, I'm going to put my point on point X. And now I'm going to swing an arc. Uh-oh, I got to goop that up. Sorry about that. That. So now I'm just kind of going to swing an arc like that. Okay, notice this intersection right here. What point is that? It's going to be my new point Y. Using my straight edge, I'm going to go from Q. And yes, I realize my intersection went all the way up to point Q. That's fine. But let's make our ruler. So now, this angle right here is identical to this angle right here. So angle Q, or angle XQY, is equivalent to angle XQY. So there's three things that take place. When you have an angle and you want to duplicate it, create some other point. So like this one we called angle Q. We create another point Q off of it. We opened our compass a certain distance. We swung an arc that went between and touched both of the lines or both of the rays that made up the angle. Kept that compass the same length. Took from point Q, just drew an arbitrary straight line with our straight edge. Took our compass, put it on point Q, swung a huge arc. Once we swung the huge arc, then we came back and measured the distance from X to Y, which was not necessarily the same distance. Put that back on our defined point, swung an arc, and where the two arcs intersect, where two arcs intersect, two lines intersect, you always create a point. How many compasses do I have? Jeez. Pick that one. All right, talk me through this next one. If I wanted to generate this angle off of point R, where do you think I should mark R on our angle? Where? Right here? Everyone with me? Is this R the same as this R? Not necessarily, but we're just using it as a reference. Next step, compass time. What should I do? Yeah. Okay, so put my pointy end on R. You agree? Open your compass a certain distance. Swing your arc. Whoa, that didn't work as I wanted it to. Undo that. No, I would just make sure that the distance that you choose here doesn't extend beyond your line. Does that make sense? So this has now created how many more points on this? 2 more points. So you have a point here, you have a point here. Now I'm going to throw a wrench in things. I'm going to do a smiley face here and a frowny face here. Those are my variables. Is that okay? Everyone still with me? I got to come down my page a smidge. My compass is still open to the appropriate distance. I have now point R here. What should I do with point R right there? Yeah. Good. I'm going to take my straight edge. Good use of terminology as well. You can make that straight edge smaller. Okay. I've just generated that. What should I do now? Yeah.
Swing a big arc or
Okay.
Oh, actually, sorry, never mind.
No, you're good. Say it.
Is it swing a big arc and then make a point?
Mm-hmm. So, making sure I don't open or close my compass at all. I'm going to bring my compass down here. I'm going to put my pointy end on R, and then what I'm going to do is I'm going to swing kind of a big arc. Okay? How big? I don't know. It might have to be bigger than that. Maybe. So I have a big arc swung. Which point is going to be smiley face versus frowny face, or does it matter? Can I label this frowny face? So that means that this point here and this point here should be the same point. Agree? So the distance from R to frowny face and R to frowny face is the same. But then I'm going to have to do one last measure in order for this to work. What am I doing with my compass and my faces? What do I do with my compass and my faces? Yeah.
You put the compass on the frowny face and then you do an arc with that.
Okay. Which arc am I going to do though? Where am I? Which frowny face? The frowny face, the new one, or the one that was on the original?
The new one.
You're almost there. We have to do one thing before that though. What distance do I not know yet? Yeah.
From the R to the smiley face?
I have the R to the smiley face. That's the whole arc that I've done. Yeah.
Isn't it the frowny face and smiley face?
Frowny to smiley. Good. So I need to measure. I need to figure out with my compass that distance right there. So I'm going to bring my compass over. Rotate it so I can see it. Does that look like it's about that distance? Okay. So without changing my compass, I'm going to bring my compass over. Okay. Now I swing this arc. So you notice the two arcs intersected. What do you know about this arc? Which point is this now? Happy face. Good. Okay. Using my straight edge, I'm going to put it on R. This is kind of a pain. Okay, so this angle right here is the exact same as this angle right here. Might be going different directions, bless you, but it's open the same amount. So this is an obtuse angle for terminology. Obtuse angle, if you remember, is larger than 90, less than 180. So same idea. Yeah?
So when we do these on the homework, is it okay if we leave all the arcs?
Please do. Because that's the thinking I can see. Okay? It's totally fine. You know, some people like to have little tiny arcs and they want to be all neat and meticulous. Awesome, that's how their mind works. Other people believe in entropy. They like the big old circles going every which way. I get both ways. Your mind's working fine either way. How do we feel? We all right? All right, so we have two last things to do. We want to find the perpendicular bisector. And then after we do that, we want to find the angle bisector of what we just did. May I move screens? Good? All right. Oh, wait. Where did that come from? 4, 5. Is that on our sheet?
No.
I don't know what this is. I don't know why that's there. Oh, is it? Is it? Oh, is it? Oh, okay. So, I wonder if I can get rid of that. All right. Question? It's just using geometric tools to duplicate a shape. That's very basic, doesn't have to be much more complex than that. We good so far? Everyone happy still? All right, let's see. Construct a perpendicular bisector of each of the segments below. Okay, what does perpendicular mean? 90 degrees. What are perpendicular slopes? If I had 3 over 5 as a slope, what's the perpendicular slope? 5 over negative 3. It's opposite reciprocals, negative reciprocals of each other. Okay, so that's the algebraic thing. If we're talking about perpendicular bisectors, perpendicular means it's going to form 90-degree angles. What does a bisector mean, though? Yeah.
Does it cut it into two?
Cuts it into 2 equal parts. Okay? This is, I feel, a fairly easy thing to do. Compass, bring it on over. Still with me on this adventure? Put your point at one end. Open your compass so it's a little bit further than halfway. Open your compass so it's a little bit further than halfway. It appears that my compass is a little bit further than halfway. Do you agree? Now, you could do this to where you had your compass all the way open. It's your choice how you want to go with it. You can have it all the way open, or you can just have it a little bit more than halfway. So if you're a little bit more than halfway, what you're going to do is now you're going to swing just kind of a big arc. Okay? Then you take your pointy end and you move it to the other side. Keeping your compass the same width. And you swing another big old arc more than halfway. Do you see where 2 new points have been established? 2 points define a line. Do you agree? So I now have a point right here. And I have a point down here. Do you agree? I'm going to use my straight edge. Make it vertical in this case. Connect the dots. So this green line is perpendicular to the original black line, meaning it forms 90-degree angles. It forms 4 of them, 1, 2, 3, and 4. This green line also, because this line just intersected, it created another point. So if I called this endpoint here X, I called this endpoint here Y, and let's call this smiley face. If it's a perpendicular bisector, it means it cuts it into 2 equal parts. So line segment X smiley face is the same distance as smiley face to Y. Make sense how I said that? It also, because we cut it in half, we created it to be perpendicular. Yeah?
Could you say that the distance to X and smiley face is the same as smiley face to the other ones that we just created at the top?
So you're saying, look, right here?
Yeah.
So that distance right there is not, that's right along this. So this distance here, is exactly the same as that there, yes. But it's not the same as the whole distance. And what we'll do with that whole distance, eventually, is they're going to ask us eventually to create an equilateral triangle, which is very much like creating a perpendicular bisector, but you do use the entire length. In this one, we just used a little bit more than half. Does that make sense how I said that? But we'll get there. Yeah.
So with these, is it okay if we use the arcs as well?
Arcs from here on out are totally chill. Cool? All right. Can somebody talk me through this next one? Hey, let me erase that and that. First thing, yeah.
You put your compass over halfway.
Okay, so oops. What's going on? Here. There we go. Make my compass over halfway. So looks like it's about over halfway. Do you agree? Swing a what? Arc. Make it big. Still with me? Keeping the compass the same, what am I going to do to get the other arc? Yeah.
Go to the other side.
Yep. Put my compass out the other side. And then swing the same arc. Just opposite. If I have two arcs crossing each other, what have I just defined? 2 points. Good. So I got a point here and a point here. Now what should I do? Yeah. Connect them. So using the straight edge, connect those points. Okay, the black and the pink dotted are perpendicular bisectors of each other. They're perpendicular. What can you tell me about the relationship between the pink line, dotted line, and the black solid line? They're perpendicular. What can you tell me about the pink dotted line and the black solid line? Yeah. You can know just what happens if they're perpendicular. What do you know? Being they're perpendicular. How many 90-degree angles? 4. Okay. And if that pink line is a perpendicular, bless you, bisector of the black line, what can you tell me about the black line and the pink line relationship? The distance of the black line, which I could call a point there, and a point there, and a point there, and we could say smiley face, frowny face, puzzled face. What can you tell me about those terms I just used? The distance, yeah.
Distance from smiley face to puzzled face is the same as puzzled face to frowny face.
There you go. That easy enough to think of? Last thing we want to do is create the angle bisector off of this. I'm going to create the angle bisector. Okay, so I'm going to pick one of the 90-degree angles. And if I bisect the 90-degree angle in half, what size angle should I get? 45 degrees. Agree? Okay. I'm going to pick this angle right here. I know that's 90 degrees. Why? By definition, I've created a perpendicular bisector. If I cut that angle in half, I am going to create two 45-degree angles within that angle. Because 45 plus 45 is 90. Everyone agree? Okay. So, get things off out of the way first. I'm going to take my compass. I'm going to open my compass a certain distance, put my point right in the center, and from that distance, oh, come on. I'm going to swing an arc all the way. Does everybody see the red arc okay? Where that red arc just intersected the black line and as well as the green line, as well as the blue, but we're just worried about the black and the green because the black and the green right now create a 90-degree angle. So I have a point right here and a point right here. Do you agree? We can label those if we'd like. There's no reason to. Okay? What I'm going to do now, keep my compass the same distance. I'm going to put my pointy end on the corner, and I'm going to swing it up. Whoop, 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 whoop. Swing there. Swing. Swing the arc. Okay? And then I'm going to keep my distance the same. Bring my compass over to here. Put my point on that. And I'm going to swing another arc. So I measured this distance here. I swung an arc. And then I came here and swung another arc with that distance. From there, that point right here, I'm going to use my straight edge. So this, oh, we got way too many colors. Let's see. All right, this right here, this pink, is the same as this right here. They're the same size angle. They're both 45 degrees. So that's how you create a bisector. Woo! That's all the notes I got for today. I want to show you something real quick. Someplace up here. Oh, so this right here. How can I make that a better look? The nice thing about this is this tells you, goes through all of the, of course I drew that, goes through all of the different things that we're drawing. So if you email me, you want to know what this site is, it has videos that don't have any language on it. It just has the construction taking place. Or if you feel comfortable with my notes, they're also being saved online. Yeah?
I just have a question on the notes. Where did you get the third arc from? The red arcs?
The reds?
Yeah.
So that was our angle. Okay, so I came here, swung a large arc. I just opened my compass, swung an arc. Keeping my compass the same size, then I put my point here and my point here, swung two more arcs. So basically it was where they intersected. That point, then that point connect, and that becomes your angle. Your assignment for tonight, if you choose to do it, why don't we do, okay, this is what we're going to do. Yep, that works. Okay, we're going to do worksheet 0.6, or jeez, 0.6, come on. Worksheet 0.6, and I want you to do 1 through 6, not worry about the word problems. And then worksheet 0.7, we're going to work on 1, 2, 3, yeah, 1, 2, 3, 4, 5, 6. So 1 through 6 on each. Don't worry about the word problems on worksheet 0.6. So word 0.6 and 0.7, 1 through 6 on each. No word problems. Okay? If you don't have your geometric tools, get them, please. They're $3 at Bare Necessities, all right? Everyone feel all right? That's geometry, man. Let's have some fun. Save it. Go ahead.
11.
Number 11. Name 3 planes that intersect at point R. Okay? So, 3 planes that intersect at point R. So I could use the right side, which is TQRS. I only need to use 3 of those letters to identify that plane. I could use the bottom, which is MPRS. You only need to use 3 of those letters to identify that plane. And then the back of this object is QOPR, and in which you only have to use 3 of those letters. Does that make sense how I just said that? Cool. Yeah.
What if you use 4?
4 is fine. Right? The minimum number of letters you need to use to identify a plane is 3 non-collinear points.
Because wouldn't 2 be a line?
2 of them would be a line. Other questions up to number 11? Yeah.
I have one on the back.
Okay. Okay, we'll get there. Anything more up to number 11? Or up to number 13, just because we're talking about the geometric stuff. 13. 13. Name 2 opposite pairs of rays.
That's all.
OA, ray OA and row OC are opposite rays, or you could also say that ray OB and OD are opposite rays. 13. Name 3 non-collinear points. ABO, AOD, DOC, COB.
But aren't D and O on the same line?
Yes. So I just need a third point that doesn't happen to lie on the line to make it non-collinear, even though 2 of them will be on the same line. Okay. Now the algebra. Questions there? Which one? 17. 1/2 x
Minus 1/4
minus 1/4
equals 3/5 x
3/5
plus 2.
plus 2. This is number what? 17? Okay. Problem number 17. So what I would do on this problem is I would clear the denominator, meaning I have 4 terms. 3 of them happen to have fractions. So what I'm going to do is I'm going to multiply all 4 of the terms by the least common multiple of 2, 4, and 5. So it's the smallest number that 2, 4, and 5 all go into. 20. So I'm going to multiply this by 20 over 1, and this by 20 over 1, and this by 20 over 1. 20 over 1 is the fraction, and this just by 20. You can say 20 over 1 is there as well, but you don't need to. So from there, 2 goes into 20 10 times. 10 times 1, I get 10x. And then 4 goes into 20 5 times. Negative 1 times 5 is negative 5. Equals 5 goes into 20 4 times. 3 times 4 is 12x, and then plus 40. And then I think from there you could probably solve it, where subtract the 10x, subtract the 40, divide by 2, and you can leave it as a mixed or improper fraction. Any others from the algebra? Yeah.
20.
20. Two x minus 3. Parentheses equals x plus 5 is 0. And it's equal to 10. Is that right?
Negative 10.
Negative 10. All right. I'm going to distribute negative 3 here and here. So I have 2x minus 3x minus 15 is equal to negative 10. Do you guys all understand why that's a negative 3x and why that's a negative 15? Is anyone stuck on that? That's a big error a lot of times, and it's easy to forget about. The negative needs to distribute over the parentheses as well. Combining like terms, so I get negative x or negative 1x minus 15 is equal to negative 10. Add 15, so I get to 5. Don't want a negative variable, multiply both sides by negative 1. So there's my answer. Are you okay? Feel okay about this? Happy day? Yeah. Anything else on this worksheet that I need to run through? Okay, so this worksheet only I'm collecting today. The other one we'll be due on Wednesday, so we'll take questions on that tomorrow, and then hopefully get through it. So make sure your name is first and last name is on this, and pass that on forward.
Wait, so that